Hello guys, this is Isaac and today we are going to talk about test for population mean. Okay. Last week we have discussed about how to construct a CI, which is a confidence interval for the population mean, and today we are moving on to another topic which related to testing. Okay. So when we say testing, we need to have some object, right? And always, usually when we have a test in statistics, we always have a hypothesis. So hypothesis means somebody's opinion. So to explain this concept, I wanted to give you a concrete example. Okay, so let's say I have a friend. So this is my friend, and I know he's really good at throwing a ball. Okay, so he can throw a ball really fast, but sometimes he's saying like ridiculous thing. So what he always saying is that he can throw, so I can throw a ball like 90 miles per hour. Personally, I admit he is a really good pitcher, but I never think he is this much of a good pitcher, because first, if he can do it, then he should go to MLB, right? And not being my friend. And second one, so since he always kept saying this, I measured. So I measured 20 of his throwing using speed gun. Okay, and I got these results. Oh. Let me go to my website. So I got these 20 numbers. Okay, so I got 77, 80, 82, 79, 75, 80, 81. So all of these measured in mile per hour, and first number means like his first throwing was 77 miles. Okay? So let's just write it down, that number. So we have 77, 80, 82, and last number was 78 and 84. So I have these 20 numbers, and after I seen this 20 number, what I did is I add them up and divide by 20 so that I can get the sample mean. Okay, and after the calculation, I got 79 as my sample average. So now we have this number, and I want to ask you a question, like what do you think of his opinion? Okay. Do you believe his opinion is true? After you see this sample average is 79? Well, I would say I don't believe it, because when I think about the probability of having x bar, which is my sample mean, is 79, is very low. It's very low if what he insists true. Okay. So how can we calculate this probability? Probability of having X bar is 79 under the assumption that his opinion is true. How can we calculate the probability? So our goal is to calculate that probability. And before I calculate the probability of that probability, what I want you to know about is that the distribution of the sample mean. Okay, we already talked about this before. So if I have a random variable follows the normal distribution, mu and sigma, and if I have a sample from this distribution, x1, x2, xn, so I have a sample, n sample, and then take the sample average. So what I want to do, I add them up and then divide by n, will give me x bar. That one follows the normal distribution, whose mean is same as the population mean. So this one is go down here, and then we knows that the standard deviation of this x bar shrink by sigma over square root of n. So we have talked about this before, right? And using this fact, I want you to calculate the probability of having x bar is 79. Okay, but since normal distribution is continuous variable, so we need to adjust this probability a little bit. Like our goal is to calculate the probability x bar is less than 79. So to test his opinion is true or not, what I want to do is I want to calculate this probability, and if this one is high, then I believe his opinion. But if this probability is really low, then I don't believe him. Okay, so as we know, we have two different opinions. First, he thinks he can throw a ball like 90 miles per hour, and another opinion is our opinion. We don't believe it, right? So using the statistical notation, I can write it down, these two opinions like this. So I have H null, which is our friend's opinion. He believes his average ball speed is 90 miles per hour. Okay, versus we have different opinion, which is H alternative. So alternative hypothesis is that, hey, your real ball speed is less than 90. Okay? And we want to test this hypothesis using by calculating the probability of x bar is less than 79, which is our sample mean. And how can we calculate this probability? We want to use the standardization formula again. So maybe this is kind of a automatic calculation. So when you think about this probability which follows some normal distribution, and you want to calculate the probability, then without thinking anything, like you should write it down T parenthesis, okay, and then write it down the Z. which represent the standard normal distribution, standard normal random variable. Okay, and same direction of the inequality, and you should convert this number to like certain number in a normal standard normal scale. Okay, and how do we convert this one? We use the standard normal standardization formula, which is 79 minus mean of this distribution, mean of this, okay, divide by standard deviation of this thing. So if we know the standard deviation of x bar and the mean of x bar, then we can plug that number in here, right? And what is the, then my question is, what is mean and standard deviation of x bar under the condition, or under the assumption H null is true? So we talked about the sampling distribution here. If I knows that if the random variable follows the normal distribution mu and sigma, our sampling distribution follows the mu sigma over square root of n, right? And we assume that H null is true, and what does that H null says to us is that it says mu is 90, right? So in this assumption, I would say x bar follows the normal distribution, mu is now 90, and we know that x bar, standard deviation of x bar shrink by sigma over square root of n, and we have 20 as our sample distribution, 20 as our number of observation. Okay, so if we know this sigma, so let's say we have 2 as our population standard deviation, then I'd say x bar follows the 92 over square root of 20, right? So we need to put this number into that formula and that number into that formula. Okay, so let me just write it down, that formula again. So this is 79 minus mean is 90, and then 2 over 20. This, let's say I would say small z, we need to plug this one here. Okay, and when you calculate that number, what I have here is this is negative 24.6. Okay, so let me just write it down. Negative 24.6 here. Okay, so what we have done is that we convert this probability of x bar is less than 79 into standard normal scale. So we have using the standardization formula, we have this probability that the standard normal random variable z is less than -26. Okay? And my follow question is that how do we calculate that probability again? Okay. So now we already knows that x bar is less than 79 is equal to probability standard normal distribution standard normal random variable is less than -24 6, and our goal is to calculate this one. And when we think about the density function of standard normal random variable, we already knows that follows the that is the bell shape whose center point is 0, and I knows that one standard deviation is 1, right? Because that's the standard normal distribution. And that -24.6 is here. When we it's here, right? -26. And we want to calculate the probability z is less than -24.6, which means area under this part, which is way less than 0, less than maybe just 1.1. So I would say 0.00001, which means impossible, right? So let's just see. 0.0001. What does this mean? This means since we have really low probability, assuming that what he's saying is true, I'd say if what he's saying is true, which means H null is true, then probability of x bar is 79 is very low. So, because I don't believe him. And in statistically, that I don't believe him means I can say I will reject your opinion based on my sample, right? Sample was 79, right? So this is the mechanism of doing testing in statistics. Okay, so before I move on to another situation, I wanna I wanna mention some statistical term you should know. Okay, so in the testing, we have calculated this. We have used this formula, right? This one. We have calculated the z value, convert the 79 into the standard normal scale, and this z, we call this g as test statistic. So z is test statistic. Okay. And based on the test statistic, we're gonna determine whether we are whether we reject the null hypothesis or not. Okay, and also the probability of this thing, the whole thing, we call this probability p-value. Okay. So if the p-value is really low, what we are going to do is we're going to reject the null hypothesis. Okay? And also, since our alternative hypothesis is this looks like this, mu is less than 90, this inequality usually equals to this one. Okay? So these are the terms you should know. And there's another term is that there's another term you should know is that the significance level. So this significance level is you can think this one as a threshold of your p-value. So let's say I want to do do 0.05 level significance level testing. That means if this means if my p-value is less than 0.05, I reject H null, otherwise cannot reject. If my p-value is larger than 0.05, we cannot reject. Oh. So these are the statistical term you should know in statistical testing about the population mean. Okay. The another situation is that previously we assume, so we have assumed we know sigma, so known sigma. But in our real life, we don't know this sigma, right? So usually we have unknown sigma. And how can we do the testing in this situation? Okay. In this situation, this maybe looks similar to the previous case for the confidence interval when we don't know the sigma. In that case, we switch and we replace the sigma with the sample standard deviation, right? So same thing, similar things happen in here. So in the testing, in the test, we have calculated small z like 79 minus mu. So mu 0 was actually 90, right? 90, and then sigma was 2, right? And let me just write it down this way. So our test statistic looks like this, right? And we have here unknown value sigma in our formula for the test statistic, right? Naturally, what we want to do, we want to do the same calculation, minus 0, but with the replaced quantity S, which is sample standard deviation. Sample STD. Since we replace this population sigma with the sample standard deviation, the whole thing does not follow the normal distribution. Now we should say this one follows another distribution, which looks really similar to the normal distribution, but we call that distribution T distribution. Okay, and if you calculate the sample standard deviation for that that 20 numbers, I got this. I got 1.974. Okay. So now I have a number 1.974 as my sample standard deviation. So my test statistic for the testing will be 79 minus, again, 90, like imaginary mu mu which came from his opinion, and we have sample standard deviation 1.974 divided by same number of observation, 20. And in this case, if you calculate that number, we have what value? Okay, let me do the calculation. So we have 79 minus 90 divided by 1.974 over square root of 20 is negative 24.92. So since we have negative 24.92 as our test statistic, what is the p-value? P-value is probability of x bar is less than negative I say t distribution, random variable which follows the t distribution is less than 24.2 is my p-value. So how do we calculate the probability of this one? Okay. To calculate this probability, you should know how to read a t-table instead of a standard normal table, okay? Which looks like this. This is our textbook table, and before we have standard normal table looks like this. We have negative number here, right? Oh, positive number here, and then what? Oh, negative number here and the positive number here. But when you move on to the t-table, t-distribution critical values, table C, we have a little bit different table than before. So on the column, we have numbers for degree of freedom, okay? And each column the name of the column indicates the cumulative distribution, or not cumulative distribution, confidence level C. Okay, so how can I say? Once I fix the degree of freedom, then I will have one specific t distribution, and for this 2.05 means for degree of freedom 5, this t star is 2.015, and then area under this one plus this one is equal to 10%. Okay, does it make sense? So area under this one and that one, so this part and that part, if you sum them up, that will be 0.1. Okay, and this area corresponds to 90. Okay, so let's just I'll go back to my thing. So we know that t distribution is also looks like normal distribution, so it will have some number there. It will center that at 0, and we will have t star here, and since it is also symmetric, I'd say this is minus t star. And area between these two numbers, this is confidence level. Okay, and so we have degree of freedom in the column on the left hand side. So let's say what is our degree of freedom in our example? Since we have 20 for our observation number, I would put 19 as a subscript T, which indicating that 19 is our degree of freedom, because degree of freedom can be calculated by n minus 1. So we have n as our 20 as our n, so minus 1 will give us the 19, right? So specifically, we are looking for the t distribution whose degree of freedom is 19. And to calculate the probability, t19 is less than negative 24.6. What should we do is that remove the sign of this, which means 24. So in the table, what I want to do is I just want to look up the numbers which is on the 19th row, and then look up the 24.6 on that line. So let's say I have 24 here, 0.6 here. Then I want to go up, and then I want to read the critical confidence level here. So maybe this one corresponds to 99 confidence level. Okay, which means if this 24.6 corresponding to the 99% confidence level, that means area under that curve and area under that curve, if I sum them, these two, I will get 0.01. Okay, so if the star 24.6, then this area and that area, summation of these two will be 0.01. Okay, so let's just go to the table. So here is my 19. And then what I want to do is I want to look up the 24.6. Okay, 24.6. So we cannot find the 24.6 because the largest one number on that line is 3.883. And if I go up there, what I can see is confidence level corresponding to that 3.883 is 99.9%. What does this mean? This means if this value is 3.883, then summation of these two is already not 0.001. Okay, so if I think about the probability of this, probability of T19 is less than 0.6. Oh wait, so let me tell you another thing. So I know that if this value is 3.883, then the table tells us that summation of these two areas is already 0.001, and I know t distribution is symmetrical with respect to the 0. Then one of the area should be half of this number. So one of them should be 0.0005. Okay, and if this value is 3.883, then this minus t star should be negative 3.883. Okay, so if I thinking about this situation, I'd say probability of T19 is less than negative 3.883 is less than is 0.005. Okay, does it make sense? So let's just go back to our case. This is our original goal, and this is our p-value, right? And when we think about the negative 24.6, it will be somewhere around here. So because I know this is less than negative 3.8, so this is just think about this is the negative 24.6, then I definitely can say that this probability is less than probability of T19 is less than 3.83, which is 0.0005. So when I think about this probability and that equality, I can say probability of T19 is less than negative 24.6 is less than 0.0005, which is way less than which is impossible to see that happen. Okay, under our friend's opinion, under the assumption that no hypothesis is true. So let's just move on to our SAS example. So in our SAS, we can do this thing using the code. So let's move on to the example in SAS. So you want to do the test in our SAS system. But unfortunately, we cannot do the z-test, which is the case where we know the population standard deviation in SES. I mean, SES does not provide that situation because it's so unrealistic. But actually, if you really want to do that, the z-test in SES, I actually write some code for that test. You can actually study of these by yourself, or if you have any question about the code for the z-test, you can always visit my office hour. But what I want to do is actually t-test in SES, okay? Which is the case where we don't know about the sample standard deviation. Okay, so basically, to do the test, the very first thing we need to do is load the data in SES. So let's just go to the virtual desktop, and then open the SES. And what I want to do, using the data line command, I want to load the data. So just go to my website. This is the template for loading the data. Copy and paste. And in here, I need to put every numbers that I have from 20 throwing. Copy and paste. There. So I have enter every single numbers for 20 throwing, and to check the result, I can use proc print data is equal to my data name is pitch data, and then run. So if I submit that, I can see that my 20 numbers are in the SES system right now. And what I want to do, I just want to calculate some basic statistic, such as proc means equal to pitch, and my variable name is speed right here. We have speed as our variable name, so speed 1. So if I run this code, I got sample mean. So number of observation is 20, and sample mean is 79, and sample standard deviation is 1.9735088. Okay? And minimum and maximum was 75 and then 84. And to do the t-test, so t-test test can be done with the proc that the procedure univariate. So this thing variate. So let's just do the normal univariate procedure. So we have used univariate procedure like this: proc univariate data, and data set name was pitch, and variable. Right. So if I run this code, what we have seen before was this. Okay, so we have univariate procedure, variable name is speed, and we have moments. So moments table, we have mean, sample standard deviation, skewness, and variance, something like this. And then we have quantiles there. And then we have information about the extreme observation. And among the table that the univariate procedure provides us is that this table. So test for location mu 0 is 0. Okay? So this is the table related to the t-test. Okay? And since we have a situation that our null hypothesis mean was 90, right? So I want to declare my mu 0 is 90. Okay? So if I submit this code into the Stat system, now I can see the mu 0 is equal to 90 in that table, and this table contains the information. Just magnify a little. So this table contains the information about the t-test. Okay, so we can see the negative 24.9269 as my t-test statistic, which is the number that we have seen before. Okay, this is the same number that we have seen before in my Blackboard. So we have calculated this t statistic and we have negative 24.9, right? And this one is same as this number. And SAS will give you the p-value which corresponding to two-side test. Okay, so in our case, our test was one side, so I should divide by this number. I should divide this number by 2, but this number already shows that my p-value is so small. So even if don't divide by 2, I can say that, oh, I can reject my null hypothesis. Okay? But if you have larger number like 0.6, then if you for this this two-side p-value, then if you have one side test, then your p-value will be half of that, which is 0.03. Okay, so just be careful. That system will give you the two-side p-value, okay, which you should adjust that based on your test. Okay, so I think I'm done today. Hope you guys enjoy the vacation.